In this video, we're going to talk about how to add rational numbers. So in other words, do you remember how to add fractions if you have a common denominator or if you don't have a common denominator? That's what we're going to review in this video. So adding rational numbers, if you are lucky enough and they already have the same denominator, a over b plus c over b, you're going to combine those together into a single fraction that has b as the denominator, and you just add the numerators together and put it over that common denominator. Now, if you're unlucky and you don't have the same denominator, you're going to have to go and find a common denominator. General practice is we find the least common denominator just because it keeps the numbers smaller and makes the math easier, and you're more likely to get to a simplified answer quicker if you use the least common denominator. And what is the least common denominator? It's the LCM. It's the least common multiple of the two denominators. So you're going to convert using equivalent fractions. You're going to convert both fractions so they have this common denominator that you want, and then you can add the numerators, but you can't do it until you have the same denominator. So this formula, it kind of leaves out a big step in the middle, and that is if you want to add a over b to c over d, if you multiply the two denominators together, that's a quick way to get a common denominator. So if we want to multiply the denominators together and get BD as our common denominator, the first fraction you'd have to multiply by D to get BD as your common denominator. So that would make AD on the top. And then the second fraction you'd have to multiply by B on the top and the bottom, and that would give you C times B, or BC on the top, and it gives you BD underneath. And see, what they're doing is they're then adding these numerators, AD and BC, together. So I'm sure you remember how to get a common denominator. Maybe you haven't done it in a while, so that's the reason why we're reviewing. So we've got 3 examples. We're going to add and try to give our answer as a simplified fraction if we can help it. So we're going to look at 4 and 6, and what is the LCM of 4 and 6, or what is the smallest number that 4 and 6 will both divide into? I think 12 would be a good denominator to use. So here's what I'm going to do. I'm going to go ahead and kind of set up the skeleton of what I'm wanting to get, and that is that I want both of these fractions to have 12 as the denominator. And now I'm going to see if I can create equivalent fractions to make that happen. So what would I have to multiply 4 by to get 12? Well, I have to multiply by 3. So I'm going to multiply top and bottom by 3, because whatever you do to the top, you have to do to the bottom, and vice versa. So 4 times 3 would give me that 12, and then 3 times 3 would actually give me 9. So 9/12 is my equivalent fraction to 3/4. Now I'm going to do the same thing over here. What would I have to multiply 6 by to get 12? I'd multiply by 2. So that means you have to multiply the top by 2. And you'll get 10/12 is the equivalent fraction to 5/6. And then what you can do is simply add the numerators. Now that we have the same denominator, we're going to get 19/12. And that's an improper fraction, and we're just going to leave it improper for right now. That's not the only way to work the problem. You could have used 24 as a common denominator. You could have used, something way bigger, 240 if you felt like it. But the smaller you keep it, the less simplifying you'll have to do at the end. All right, the next one has 3 and 25 as the denominators. So obviously that one does not have a common denominator, so we're going to have to create a common denominator. I think 75, just multiplying those together, 75 would be a good choice. So again, I'm going to go ahead and set up, kind of manifesting here what I want. I'm setting up the fractions with the denominator that I want. I would have to multiply 3 by 25 to get 75. So that means I also have to multiply the top by 25. Now that's a -2 times 25. That's going to give us a -50. For the second fraction, I'd have to multiply 25 by 3 to get 75. So I also multiply the top by 3. And I'm going to end up with -50 75ths plus 3 75ths. So since they're both 75ths, you just have to add the numerators. And -50 plus 3 is -47. And negative 47, well, 47 itself is a prime number, so this can't be simplified. That's as simplified as this one gets. Negative 47 over 75. Make sure you get the negative in there. Now for the last one, we're going to be adding three fractions together. So we have to come up with an agreement for the denominator that works for all of the fractions. So the smallest number that 4, 6, and 12 will all divide into is 12. So I'm going to set up all of these fractions so that they have 12 in the denominator. Now the last fraction already has a 12, so I don't have to do anything to the last fraction, but I am going to have to convert the first two fractions so they have 12 as the denominator. So the first fraction I'm going to have to multiply by 3 over 3. Second fraction I'm going to multiply by 2 over 2. You see, the math isn't terribly difficult because the numbers are pretty small, and then you just have to add up your numerators. So 9 plus 10 plus 1 is 20. So we actually get 20 over, 12 there. 20 over 12. But we need to reduce this if it's possible. So let's see. 20 is 2 times 10. 12 is 2 times 6. So I know that those 2's will cancel. And 10 is 2 times 5, and 6 is 2 times 3. So I know those 2's will cancel. And there we can get 5/3 as our final answer. We're going to leave it as an improper fraction. So just make sure you reduce that final answer if it's possible. And there's a lot of ways you can go about reducing it, whatever method you want to use to reduce it, but that's just what I used. So that's how you add fractions.